Okay, so we just made this one up. Let's see how this goes. And the vertex should be done pretty much the same way. So let's see that vertex formula. So the first thing I would want on this is my x value for my vertex, because this is a vertex. And to solve it, we see that the x value is negative b over 2 times a. Well, in this problem, I have a b value here that's negative 9, and I have an a value that's 16. So the b I replace with negative 9, and the a I replace with 16. This will be fractional, and that's okay. But let's see what this shows in my calculator. So 9 over 32. Oh crap, I was in the wrong mode. That appears like it will not be simplified, so it's just 9 over 32. Now that's my x value there for my vertex. What I then need is my y value. So I'm just going to use my calculator. Again, I'm just replacing these x's with 9 over 32. So I'm actually going to store that in for x right there. But I got 16x squared minus 9x plus 25, enter. Ooh, it's a pretty ugly, oh, it's way ugly. When I put that 932 in the calculator, it gives me 1,519/64. It's possible, it's just possible that the decimals may be handy here. So 9 divided by 32, I'm going to round these to the nearest hundredth. I got 0.28. And then the other one, the 1,519 over 64. Let's change that into a decimal. I got 23.7. Rounded.
Sorry, how do you get that number?
All right, now we do have the vertex, which is great. It's great news. In fact, let's box it in because it's so great. Okay, so we do have the vertex. It says the x value, the largest x-intercept is x equals something. I'm assuming right now that this cannot be factored. Now, whether it can or not doesn't matter, because I can just use the quadratic formula to find my x-intercepts. And that would be great, because then I don't have to worry about factoring. Maybe you do want to worry about factoring. You could see if you wanted to. I'm just not going to do it. So I'm going to use my quadratic formula here. I'm just going to do it once, though. So we got all this stuff. Remember, b squared minus 4ac. Now in the problem, we see that our a value is 16, so that'd be 4 times a times c. Oh, I forgot my 2 on the bottom, right? So that'd be 2 times 16. And then my b value is 9, negative 9. So it's a negative 9, but remember the b to start out there was negative 9. And then we got a b squared in there, so that's a negative 9 squared. And then my corresponding c value there is the 25, that constant, right? So c here is 25. So it's in the discriminant, b squared minus 4ac, so I now know my c is 25. This is looking like it's going to be, I put 22, should be 25. This appears like it will be imaginary to me. Let's find out for sure. So a little bit of evaluation here because I'm worried that it will. I'm just going to worry about the discriminant. Yeah, my discriminant is negative. So here's what this means as well. I still got plus or minus, and that's good. This would have just ended up being, let's evaluate some of this. So we got 9, and then it would have been the square root. The discriminant that I got was negative 1,519. And then the denominator, 2 times 16, that's 32. What this means is that that negative is going to have to come out as an imaginary number. What does this mean? It means that there are no x-intercepts. So in this one, just because we made this one up, we didn't know that was going to happen until we did it, but there are no x-intercepts. Yeah, if you were to graph this equation, that means that the parabola does not go through the x-axis. So there are no x-intercepts except in our imagination. Or in some math nerd's imagination somewhere, some different dimension. I feel like there's a Dragon Ball Z reference in there, but I'll skip it. Okay, now the y value of the y-intercept, that's not bad, because for all of our y-intercepts, we know that the x value is 0. So really all we're going to do is replace all the x's here in the original function with 0. And so 16 times 0 and minus 9 times 0, that's all zeros. And we're just really left with that 25 right there. So this is my y-intercept. And, well, that's as much as we need, I believe. This one's my y-intercept. So this one came out with no x-intercept because we made this one up. But if you had found that this discriminant was positive, you may have irrational values, and that's okay. Remember, you would look for the positive one, though, because hopefully this number is positive, but you'd have something plus something else divided by something is going to give you positive. Usually if you subtract it, give you something smaller. Yeah. Unless maybe these values are negative for some reason. But either way, that's the way this one came out, just no x-intercepts. So we can't say one's bigger than the other.